Hello, in this video, I will go over how to graph a quadratic function in standard form and how to find the vertex when in standard form. So the previous section we did vertex form. Now we're going to do something with standard form. So a standard form is y equals ax squared plus bx plus c. It's the same method for graphing a quadratic function. The only difference is there's a bit more work finding the vertex. So that's really pretty much the difference. So to find the vertex of a quadratic function in standard form, you must use the formula, this. So to find the x value of the vertex, you have to use opposite b over 2a. And then to find the y value of the vertex is basically whatever your x value is, you plug it back into the function. So that's what it means. Okay. Okay, so let's just find the vertex. We're not going to graph this one. So on this example, I want you to find the vertex of the quadratic standard form of y equals negative x squared plus 6x minus 8. So yeah, I'm only asking for a vertex. So first, let's figure out our a, b, and c because that's very important. So our a value is -1. Basically, it's the coefficient of the highest power. B is, wait, do you like blue? I think blue is better. B is going to be 6. Coefficient of x is 6, and then c is the constant. Okay, so once we know that, we could find the x value, which is opposite of b over 2a. So the opposite of b is -6, and then it's 2 times a, which is -1. And then you have -6 over -2, which is +3. And then, so your x coordinate of the vertex is 3. Now let's find the y value by simply plugging 3 into the function, right? So it's negative parentheses 3 squared plus 6 times 3 minus 8, right? So 3 squared is 9, and then you have a minus, so that's -9. 6 times 3 is 18 minus 8, correct? And when you put it all together, you get 1. Okay, so that is our vertex is going to be 3, 1. So yeah, there is a bit more work, but that's really just the difference. Everything else is the same. So let's start graphing. So on example 1, graph the standard function of a quadratic function. Completely find vertex, y-intercept, x-intercept if possible using discriminant rule. Axis symmetry, domain, and range. Okay, so let's find the vertex. That's very important. So our A is 1, B is 8, and C is 11. So X is opposite of B, which is -8, all over 2 times A, which is 1. So that's -8 over 2, which is -4. Okay, now we're going to plug in -4 into the function. So that's going to be -4 squared plus 8 times -4 plus 11. And when you put it all together, you get an output of -5. So your vertex is going to be -4, -5. Okay, let me confirm it with Desmo. Yes, the vertex is definitely -4, -5. Okay, So once we have the vertex, the next thing I would find is a axis symmetry because it's related to the vertex. So it's basically x equals the x value of the coordinate of your vertex, which is -4. And then let's find the y-intercept. So to find the y-intercept, you simply plug in 0 into the function. Which is 11. So your y-intercept is 0, 11. Yeah. Okay, so we found that. Let's find our x-intercept. So let's apply the discriminant rule just to make sure, save us time. So it's discriminant rule is b squared minus 4ac. So it's going to be our b is 8 minus 4 times a is 1 and c is 11. So that's 64 minus -4 times 11 is -44. That's 20. So that's definitely greater than 0. So that means we do have we have two x-intercepts. So just looking at it, it doesn't factor right nicely. It doesn't factor nicely. So if it doesn't factor nicely, what you do is use the quadratic formula. So x is quadratic formula is opposite of b, which is -8 plus or minus root b squared. I could do that in my head, 64 minus 4 times a, which is 1, and c is 11, all over 2 times a. So that's -4 times 11 is -44. That's square root of 20, all over 2. Now I don't want to simplify, I actually need a number, so it's going to be your first x-intercept would be -8 plus radical 20 all over 2, which is -1.76. So really it's just like -1.8. And then your other x-intercept is -8 minus radical 20 all over 2. That's -6.2. So your two x-intercepts are -6.2, 0, and the other one is -1.8, 0. Okay, I guess we can graph it. I'm just gonna have to draw it real quick. Vertex is at -4, -5, 2, 3, 4, 2, 3, 4, 5. What's my y-intercept? My y-intercept is 0, 11. So let's pretend this is 11. And what else? Our x-intercepts are -6.2. Negative 6.2 should be right about here, approximately, and then negative 1.8 right there. Okay, connect the dots. Okay, and if you want to draw the axis symmetry, is x equals -4, so it'd be right here. Okay, so there's our graph. What would be our domain? The domain is all real numbers. And then my range is, so my smallest y value is -5. Oh, and they included, so bracket -5. And our highest y value is +infinity. Okay, that's that. Yeah, go ahead and pause, and I guess we can try example 2. Example 2 says graph the standard quadratic, find vertex, y-intercept, x-intercept if possible, axis symmetry, domain and range. So, okay, so let's figure out our A, B, and C. So my A is 1, B is 10, and C is 14. So x is opposite of B, which is -10, all over 2 times 1, because our A is 1. So that's -10 over 2, which is -5. And then plug in -5 into the function to find your y. -5 squared plus 10 times -5 plus 14. Let me put that in the calculator. That's -11. Okay, let me confirm it with Desmo. -5 and -11. Perfect. So, and then my axis symmetry is AOS is x equals the x value of the vertex, which is -5. And then let me find the y-intercept. So plugging y-intercept is going to be f of 0, which is so it's just going to be 0, 14. Okay, and then let's find the x-intercept. So set y to 0. Well, first let's determine if we have any so discriminant rule. So b squared minus 4ac. So b is 10 minus 4 times a is 1 and c is 14. So that's 100 minus 56, which is 44. So it's still greater than 0, so definitely we have two x-intercepts. Let's find it. So it doesn't factor 7, 2, 8, 9. Yeah, so we're gonna unfortunately do the quadratic formula. So x is opposite of b, which is -10, plus or minus root b squared, which is 100, minus 4 times a, which is 1, and c is 14, all over 2a. That's -56, so 100 minus 56 is 44. So my two x-intercepts are negative 10 plus square root of 44 all over 2. So that's negative 1.7, which is negative 10, and then your other one is negative 10 minus radical 44 all over 2. Which is negative 8.3. Okay, so my two x-intercepts are negative 1.7 comma 0, and then negative 8.3 comma 0. Okay, so x vertex is negative 5, negative 11. So 1, 2, 3, 4, 5. 11 is negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Y-intercept is 0, 14. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And my two x-intercepts are negative 1.7, be right here, and then negative 8.36, 8, 9. Okay, so this is what your graph should look like. Axis of symmetry is x equals negative 5, so there's like a very well asymptote like this. Okay, and then find domain and range. The domain is all real numbers, and then the range is not all real numbers. It's smallest y value to largest y value. So our smallest y value is negative 11, and they include it. So bracket negative 11, comma, and our highest y value just shoots up to infinity. So it's infinity parentheses. Okay, yeah, go ahead and pause to write down all that, and we will do the other examples in another video. Okay, thank you.